In this question, we want the vector AC, which I'm drawing on now. So we need to use little a and little c to get there. And what we can do is we can go from A to O, and that's going to be minus a, little a, and then from O to C, and that will get us from A to C. So we'll then add on little c, and that's our answer. OP, right, to get from O to P, let's think of another route that we could take using little a and little c. Well, we could go from O to A to start with, and that's going to be A. And then we want to go half of AC. Because it tells us that P is the midpoint of AC, I can do a half of my answer to the previous question. Notice I'm underlining my vectors. That's just good practice when you're dealing with vectors. We can't make them bold like they are in the question. Okay, so we're nearly done. We just need to then simplify this. Let's ask this to simplify it. Little a minus a half a, when I expand this bracket, minus a half c, plus a half c rather, and then that's going to give me a half a plus a half c. That's my simplified vector OP. Finally, it says, hence prove that diagonals of a parallelogram bisect one another. So how are we going to do this? Well, we already know that P is the midpoint. So we already know that AP bisects, AP equals PC. Okay, they're the same length. So what we now need to look at is OB. So if we can show that this length is the same as this length, then we are done. We'll show, it will result that we need to also basically show that P, like they're going to intersect at OP, because, for example, you could have like this and this being the same length, but potentially, but that doesn't mean that they bisect one another. So in any case, let's just look at this. A good idea, because we found OP, really good idea would be to try and find OB, and that will equal. So we're going to go from O to A, which is A, and then we're going to go from A to B, which is little c. But if we look at it now and compare with OP, we see that it's twice that. It's 2 lots of OP. That's basically what we need. We've basically shown that OB goes directly through P, because that's what this is saying, and secondly, it's twice the amount, so it splits it into 2. So OP equals PB, and P is where the diagonals intersect, and that's it. That's all we need to say. To be honest, I'm writing quite a lot here. The main thing is the result follows. Just to write this at the end. Result follows. You could even write the diagonals of a parallelogram bisect one another, but I think I've shown enough by writing this down.